As part of this particular topic, we are going to discuss more on what are cloud infrastructure, what cloud infrastructure will include, how day zero, day one, day two happens in the data center perspective when you set up an infrastructure. When you set up an infrastructure, how are you going to make sure the automation and how do you provision, how do you configure, all these important aspects which we are going to talk about it. That is the first topic. The second topic is while setting up any data center, one has to understand more deeper on the service level agreement, service level objectives related to the communication service provider, CSPs, right? The third topic is all about the site reliability engineering, which is a new topic and a new subject altogether in an industry wherein people talk about the DevOps, people talk about the SRE. We will discuss more into the what are the best practices, what kind of features which we're going to get out of SRE. And last but not the least, as Prakash did mention about and highlighted some of the tools related to the CI/CD, today we are going to touch base a little bit on what could be the future of CI/CD. How are we going to leverage the GitOps? All of these topics which we are going to cover in today's session. So feel free to ask any questions within the session or outside this particular session. We are going to leave you the credentials, what we have, and then you can able to connect with us. Okay. So first, before getting into the cloud infrastructure, I would like to talk more on to the traditional infrastructure, what we have, where you have the traditional data center sitting in tons of servers sitting in one particular location and then connecting to the rest of the world. That is what the traditional architecture. The second one is more of a containerized architecture where servers, storage, compute, all is all in the virtualized environment. How I am kind of differentiating between virtual environment with the containerized environment, right? So, and then the third is when you talk about the virtual and the container, I am getting into the orchestration mode. How are you going to monitor? How are you going to orchestrate and automate the existing infrastructure without having any interruption in my existing data center setup? So this is all fine, but today we are operating in the multi-cloud environment, be it Amazon Cloud, be it Google Cloud, be it Azure, VMware Cloud, whatnot, right? So how do you differentiate among these different cloud vendors? Is there any specific platform I need to look into it? So some of these complexity involved in the infrastructure setup. So if you look at it, what are the drivers? When you talk about the change drivers, some of the voices are coming out from the industry thought leaders. There are three things are coming in our way. One is about the innovation, speed, and the efficiency. When I say the innovation, anything and everything which we do, definitely some kind of an improvement is coming up. So if you look at in the Japanese way of doing things, Kaizen model, more of a service improvements. That's where this innovation is coming in. Providing the cloud services to the enterprise, that is one key. Second is an agility. How agile you are while providing an infrastructure. That is the speed. If I want it today, yes, I need right now. That kind of a thing we're talking about. So those days are gone wherein you look at the current pandemic situation. If you were in 10 years back, you want to get a vaccination or you want to get any kind of a drug, we could have taken few years to a decade to identify a vaccination. But today it's not the case. That's what we are talking about. The bring products to market much quicker and faster. While doing the innovation, the speed, efficiency is more important than anything else. How efficient and effectively you are delivering the products to the market. So these three things are important, what we hear from the different customers. Next, let's talk about the operator drivers from when it comes to the cloud transformation. These are four different things. One is how do you segregate the software and the hardware? I don't want to get locked into one particular vendor and lock for the rest of the life. Those days are gone. How do you separate? Second is time to market, TTM. How do you address the new services, reduce time to market? That is how you can able to launch the new services to support my customer need. Third and fourth are important thing is OpEx and the CapEx. How do you reduce your operational expenses? how do you reduce your capital expenses, right? If you look at from 2G, 3G, 4G, and 5G, when it comes to the telcos, right? Looking in India, be it Airtel, Reliance, or BSNL, majority of our service providers, they put lot of infrastructure even for the 2G and 3G. When the 4G comes in, what happens to that infrastructure? They have to wipe it out and then move into the different infrastructure altogether. Now we're talking about 4G to 5G. 5G infrastructure is completely different. This is one of the reasons we are talking about the automation, how best I can able to bring in the new innovation, how best I can bring in the new processes and new thought processes. So coming back to some of these different stacks, which I would like to touch base: consultancy, infrastructure transformation execution, application migration, application transformation, operation transformation, and then the full service fulfillment. When I talk about the full service fulfillment, it is more into the quality of service, quality of an engagement. How do you do a customer from end-to-end delivery? Right? That's where this operational transformation is coming in. Today, majority of the industry thought leaders are talking about technology transformation as well as an operational transformation. That's where our digital transformation is coming in. When I talk about the operational transformation, it is about the change management. It is about the organizational changes, right? It is about the service performance. How do you make sure you get the proper analysis of your own processes? That's where the change is happening. As you always say, change is the only constant, right? Then the third element is the application transformation. So those days are gone wherein I have been using the legacy applications. If I wanted to move from legacy to the new applications, first I have to do an assessment. Based upon my assessment, then only I can give a recommendations, then only I do a feasibility study, then only I can do the test and validation so that I can give the better services to the customer. Once I do that, I will have an application migration. After an assessment, when I give a end-to-end migration recommendations, I have to get into the application migrations by leveraging the lot of tools, either open source as well as the proprietary tools are available today. Once I do this, planning for the application migration, I'll get into the infrastructure transformation execution. When I talk about the infrastructure transformation execution, this is about transforming the existing infrastructure to the next level, right? What does it mean is, as I was giving an example about 2G to 5G infrastructure, it's exactly the same thing. Is my servers are capable enough to handle my bandwidth? Is my server has the capacity to do a latencies, bandwidth in terms of supporting the thousands and thousands of customers, right? Then in order to do all this, I have this consultancy services as well. As is to be an infrastructure, as is to be some of the service model is becoming a norm of an industry today. Just I wanted to highlight about this so that I can get into a more detailed discussion about the cloud infrastructure. Now, when I talk about the cloud infrastructure, it's all about the virtual infrastructure. We are living in a virtual cloud, right? What this virtual infrastructure consists of virtual servers, virtual PCs, network switches, memory, storage clusters. Each and every component is all virtual environment, right? If I wanted to deploy 3G kind of a setup, I could have deployed thousands of servers with the network configurations. Today, I will not do that because I do have the virtualized server environment. I do have the virtual switches. I do have the virtual hub. Each and everything we are talking about is virtual environment. So for me, the cloud, setting up the cloud infrastructure is much, much easier compared to 10 years ago. So let's move on. So if I talk about the cloud infrastructure, what could be your day zero operations? What could be your day one, day two, and so on and so forth? When I say the day zero operations, when it comes to any kind of a data center or any kind of a server setup, first I need to sit with my customer, understand the requirements. It's more of a requirement gathering. It's more of a conducting a different workshops to the customer because they will have hundreds of different platforms, the different architectures, different design, all these things I gather within the day 0 setup. Then when I go to day 1, because I have already planned, I did a workshop with the customer. I gathered the information. Based upon that, I started planning. Once my design phase is over, I getting into a planning phase. Before planning, in the day 1 operations, I'm getting into installation, setup, and configuration. Right? Based upon my planning, I already started deploying my setup. Once I complete my day 1 operations, it is more of a day 2 operations. It's like a maintenance mode. It's like the setup is already up and running, and then it has to be on its own. That's where this maintenance and housekeeping and how do I optimize, right? So I already deployed hundreds of servers, and then I started getting so many issues related to my own network configurations, or it could be in my infrastructure, it could be my storage capacity is full, I'm not able to control. All these activities are happening in my day 2. Once I complete, let's say this setup has been completed by 5 to 10 years now. What is it I should do? Because it's almost getting into a depleted mode. It's almost getting into outdated mode. The technologies are increasing super fast. That's when I need to clean up and then the delete. It's kind of a recycle process. So just to show you in a pictorial way, day 0, as I said, the planning and design, and day 1 is more of a development starts. And then when it comes to the day 2, as Prakash mentioned in our first session, CI/CD. How do you do your continuous integration? How do you continuous deployment, continuous delivery? Then I can add one more C here. I will make it as a continuous operations. I can add one more C here, continuous customer service. This is what I wanted to get into a mode of going live with the 24/7, because these are all the mission critical applications are running. I don't want to see any level of disruptions. That's why you see here, there is a feedback loop in order to get how do you observe, orient, and decide and act based upon my activities going on here. Any kind of an applications, any kind of an infrastructure, this has to, I have to create the new CI/CD pipeline, because I will end up working with multiple technology partners, multiple system integrators as well. So this is becoming a crucial for these days. One more point I did mention, I will get rid of this CI/CD pipeline altogether. That's when I'm talking about the GitOps now. How I'm bringing in the AI ops, artificial intelligence operations. Is the GitOps is capable enough to talk about this CI/CD pipeline? So some of those key aspects which we'll touch base almost at the end of this session. So let me get into the different tools which we are leveraging it. So since Prakash is a veteran here, I would like to request Prakash to talk about some of these tools which we are leveraging for the infrastructure. Prakash, please.
Thank you, Ganesh. You are able to hear me, right? I want to confirm that. Yeah, okay. So the tools that are there, when we started earlier, most of the time we used to use shell scripts. Then slowly and steadily it went into tools, and Chef was the earliest tool based on Ruby, which was the language then used for automation. Then it moved to Puppet, as a lot of people wanted to do in a language which is much easier for them rather than doing in Ruby. And they ended up in bringing in the Python and all this. But then again, C, shell script integration, all that, Puppet had some good playbooks, they used to call it. That's where the Ansible entered the picture. And Ansible has been one of the strongest players. It is still being used, and it is there are public version as well as open version as well as vendor versions like Tower from Red Hat. And Ansible has stuck to this is also part of the stack. Actually, Salt Stack is the one which is similar to Ansible, and it actually uses the similar concept of minion and agents and all that. These are agent-based and agentless, so there are multiple of them, and those are the ones which are important to absorb. Obviously, then moving on, there are other in dashboard management dashboards like thing. And Vagrant is usually for virtualization that you use for normally for simulation and trying to test it in your own laptops and all. So that is good for developer. Then the cloud CF engine, that's the cloud formation, and AWS is the one which enabled it, and the OpenStack Heat is also similarly based on CF. And then you got uh, Packer, that is the one which is used from Packet, who have the working with Dell, they developed that. Then Terraform is the one which is come from what do you call the Helion, or the one which is used by HP and Google and all those. And Terraform manages, you can do, it's a third party dashboard through which you can even manage OpenStack and everything, including Kubernetes and all. Then your Cloud Init. Cloud Init is the initialization that occurs usually in the bare metal implementations, where they try to do the init for the booting and operations and all that. So you have got a basically all based on some kind of templates or blueprints they call, which runs from the infrastructure template to management template to the install and applications and then deployment and all. So this is all about the tools, and this is a wide variety which Ganesh has presented here. I think I should stop here. This is good enough for you. You can do research and probe and see what fits your bill and adopt accordingly.
Thank you so much, Prakash. Yes, as Prakash rightly mentioned, majority of these tools are open source. In order to create your own templates, in order to build your own blueprints and manage, install, and even the deploy the configurations, definitely you can able to use any of these tools. Not necessarily all the tools, but at least any of those tools which you can explore. Thank you very much. So now, as you saw in the previous slide, I just stopped installing and deploy. Once you do a deployment, is there any way I can reduce my activities? Is there any way I can optimize? That's what this automation keyword is coming in. That's when I wanted to provision. Is there any way I can optimize is one. Second is there any way I can provision my infrastructure for the better utilization of the resources, right? So automated provisioning is all about the self-service provisioning. We do have one particular tool called the self-service. ServiceNow is one of the great tool which we have. ServiceNow has been integrated and then very well working with the VMware products as well, right? So when I say the self-service provisioning, from the automation point of view, you can do the job scheduling, IT process automation, workload automation, or even the managing the file transfer or infrastructure provisioning. So all these activities can be done. But is automation is good enough to take care of all the activities? Not necessarily, right? How do you scale? How do you expand? That's where the orchestration is coming in. There are so many products doesn't expose their APIs, right? Once I get an exposed API, I take it and then probably I can orchestrate to develop my own customized products. That's where this DevOps and the Agile teams are coming into a major player in the orchestration world. Now, as we saw the cloud infrastructure, I just wanted to touch base from the service level agreement point of view. When I mentioned the day 0, day 1, day 2, each and every stage, we have to have the service level agreements. This agreement is typically give you kind of a measurement, kind of a KPIs, right? If I promise you to give you a support within 30 minutes to 30 days, if I'm not able to do it, definitely there will be a penalty. So that kind of an agreement we're talking about here, all right? So some of the best practices, at least from the service provider point of view, they follow. One is about the performance. Second is about the availability. What kind of available resources I have? Can I able to access these different parameters? Second is the data considerations. Is the data, whatever is available is enough? Can I expand my data, right? Is there any risk and reliability sources? Then the service level failures, application responsiveness. right? If I ping, I should be in a position to get back the response within microseconds or the milliseconds. If I start getting within a minute, that's what the responsiveness is all about. It has to be quick, right? Create a disaster recovery plan. Let's say today I'm presenting to you, I'm talking to you over this Zoom session, right? If there is a failure in my network, if there is a failure in my bandwidth, do I have any support mechanism where I can switch over immediately and then talk to you without any interruption? That's what this disaster recovery plan I'm talking about, right? Then what could be my exit plan? You have already set up your infrastructure, you've already maintained. When do you want to exit from this particular agreement? I should have my exit plan. So all these different practices are part of the SLA. I would like to talk about some of the criteria. What are the key criteria to have the effective SLA? Majority of the stuff, as you know, everybody looking at the 24/7 kind of an activities, right? So uptime could be 99.99%. That's what the availability is all about. It has to be weekends, it has to be day and night, right? Performance, maximum response time. Third is the security, privacy of the data. How do I know that my data is secure? How do I know that whatever I'm talking about is already encrypted? It shouldn't be leaked information, right? Fourth is I already spoke about the disaster recovery expectations. What is my expectations, right? And then the location of the data. If the data is in one particular location, if I'm not able to access it, then again, that is a failure, right? Then the accessibility of the data, portability of the data. What does it mean, the portability, right? So I can able to access through my mobile, access through the browser. When I say again the mobile, is it an Android phone or is it an iPhone, Windows phone, anything? That's where the different platforms should be coming in, right? Then the process to identify the problems and the resolutions expectations. If I log a ticket today, what could be my response time? I cannot wait for minutes or months or that kind of a thing, right? Earlier, if you look at it, any kind of a BSNL issue comes in even today. I would like to highlight this, nothing wrong in it, right? There is always a saying that if there is a connection coming, never ends. If it goes off, it's very difficult for me to get back that connection if I'm using one of the service providers. But today, that's not the case. Everybody is up and running, right? If there is a failure, field engineers are always in the field and then they wanted to make sure, okay, where is the failure? That kind of a monitoring systems are available today, right? In order to do that, what is my change management process? Do I have the change management process in place? Is there any mediation process? Again, the exit strategy. So some of these different criteria which we kind of look into when we create a service level agreements. Now, in the third topic, as I was talking about the DevOps, if you look at it, this is split world, right? One is the development, dev, and then the operations. Development is more into the cloud native architecture in today's world, and operations is I'm getting into an SRE mode, which is a job function, site reliability engineering, right? So let me talk more about this DevOps and then the service reliability engineering. What is this SRE, right? SRE is majorly focusing on previous slides. I was talking about the service level agreements, right? SRE is not just talking about the service level agreement. It has its own service level indicators. It has its own objectives to achieve. End objectives are very important for me to show the performance numbers and the kind of agreements I have, how reliable my systems are, right? What could be the performance? All these things are very important to show my efficiency to my customers. That is the, if you look at this, right, primary goal of SRE is to improve performance and bring in the operational efficiency. That's it. If I talk about some of the best practices for SRE, error-free budgets, right? If I allocate 100 million for this particular project, how do you allocate this? At the end of the project, I am held responsible to showcase my finances. Second, define SLOs like a user, service level objectives. Third, monitoring errors and availability. There are different tools are available today. Fourth, efficiently planning capacity. How do you plan the capacity? Because when the peak hour happens, definitely you need to have more servers and then more capacity is required, right? And then the pay attention to the change management. There is a change management process already there. There are change agents are there. Change agents, no need a human intervention. Change agents are nothing but your bots. Some kind of a script, it is in a position to respond to your need. Then there is no need to blame saying that, okay, this guy is done, that guy is done. No. Let's do the post-mortem analysis, give back to as a feedback mechanism. So I'm talking about some of these best practices. Let me hear more from the Prakash, because he has been involved in the SRE. So what are your thought process, Prakash?
So I think you covered the best practices very well. In reality, if you go into any of these clouds, example, if I take Google Cloud.
Maybe I will bring in some of these topics. You can talk about it also. Yeah.
Yeah. So what happens is, example, in this case, we are talking about remediation and figuring out troubleshooting and what is the, to overcome, what do we need to do. So DevOps tools is one, but even DevOps can be automated in the sense that you have GitHubs. So what happens is you put down whatever you do, automate it and put it in a folder under version control of Git, and let the automation scripts pull up from there. So if an alert occurs, it can pull up from there and directly react to it rather than a human intervention. So essentially, machine automation can be brought in, which is the closed loop control system, we call it. So you will find that we can have remediation based on the failures, and detecting the failures, or even predicting the failures and reacting to that. Same way for the software development lifecycle, we can do zero downtime, which is to make sure that whenever we develop something, and if in the development process, if some patches get into errors, and so we can go back from one version to the previous version. So these are on the spot. They can do fallback so that you don't have any downtime. Because in deployment, you may have one version running, like OpenStack, I'm running, let's say, W version, and then I have to fall back on the Y version, which is better, or I have to fall back into Rocky R version because there was something, the patch created some issues. So this way you can fall back on the spot without really affecting the other workloads. So part of the workloads can be running on one version, part can be another. So those are the elements which we can bring in, even during development, during staging, and during testing, and during production. So all can run simultaneously from a Git or a version control, where your Helm like operators are available, which can really engineer that. Similarly, incremental changes, like you go ahead and change a firmware. Now the firmware can impact the entire, can bring down the whole thing. So you'll have to manage it one at a time. So you do, like example, if I have 10,000 racks, and I want to start only with the first 2 racks, then go to the next 2 racks, and or try out all the rack combination. I have one Dell rack, I have one HP rack, I have one VMware rack, and so try it 2-3 places, sample, and I know it works. Then I go ahead and deploy it automatically. So these are some of the incremental changes that we can bring in, so that it is able to manage the operation well. At the same time, you measure, as you say, key measurements. We do have to have times for everything, because our downtime cannot be tolerated by any of the especially telco operations. They want everything real time. In fact, they get by not meeting the measurement, if we don't measure and if we don't project, you get lawsuits, especially in governments. You are fined, because if there is a disaster and your system was supposed to work, it didn't work, and you lose millions and millions. So how do you measure? How do you make sure that your service levels are appropriate? So even from that point of view, telcos are, that's why there is a difference between the telco and the enterprise cloud, because telco cloud, they have to be absolutely 99.99%, 5 nines. Whereas some tolerance is there that is why you will find a lot of cloud players, they give it as a beta offering so that they don't have to get into the liability issues. But those are the important factors, and key measurements in CI/CD is obviously going to be, it has to be a closed loop operation, so that you know that when you measure, if you find the performance is going down, you immediately bring in more resources, or you replace, you don't do a rip and replace, rather you incrementally replace. That's what the context here is. I hope I have given context to this. Thank you.
Thank you so much, Prakash. Yeah, let's move on. So as you heard more into the service reliability engineering and the different DevOps, I just wanted to connect you into the Tosca model. So as you saw, how do you create the templates? How do you create the blueprints for any kind of a data center setup, any kind of a change model, all of that, right? That's where the automation is playing a bigger role for creating the Tosca blueprint when it comes to the telco cloud. So when I mentioned the Tosca here, these are the different stages: design, deploy, publish, reuse, manage, and deploy. Right? Out of these, I just wanted to connect the dots. One is about what kind of open source and commercial tooling is used. Second is for reusable and composable Tosca service. And third is how do you orchestrate, right? So these three different players, one is about the tooling, second is the service, and the third is orchestration, right? So these different components are coming together and then creating a different level of dashboards for cloud providers, for the infrastructure, for the marketplace, for the management tools, and even for the application modeling. So all these things put together, we talk about the Tosca modeling. It's one of the industry best practice which we talk about. So that is, I just wanted to touch base about this model. It's just kind of a updating to you. If you find time or more, I encourage you to get into understanding about this Tosca model. So in next subsequent slides, I just wanted to connect what kind of a different tools and the different platforms are available in the open source scenario, be it hardware, virtualization software as a management, cloud platform, infrastructure as a service, PaaS, right? SaaS models, cloud management, cloud broker platform, all these different tools which you find here. Some places it is open source, some places it is proprietary, but we have an access to majority of these open source components. But in addition to this, I would like to show in the different versions when it comes to open source, right? Look at this, open source application servers. Sorry, it's a little blur, but you can able to see it in your own slides format. So open source mobile OS, and then you have this different applications are running, open source middleware, the databases, right? Analytics database, even the open source security, right? Software, all these different components which we talk about here, it's all available. There are plenty of tools, plenty of technologies available. It is up to us which one we have to take care, right? In order to do any kind of a projects within your own university, within your own field, you can pick up any of these tools and then start allowing your own students to leverage these tools, because these are the wonderful tools and they can start contributing back to the open source community. So that's what my suggestion and the request to all of the teaching fraternity here, right? So last topic which we wanted to cover today is about the GitOps, right? So the GitOps is all about some of the operational framework based out of the DevOps best practices. As we have seen the DevOps best practices, so in addition to the DevOps best practices, we wanted to cover more into the version control. How do you build the collaboration? Is there any compliances? CI/CD pipeline I talk about. All these put together, we created a kind of an operational framework, call it as a GitOps in a nutshell. If you look at here, you have this CI/CD pipeline, you have this Git repository, you have these different types of codes. One is infra as a code, config management, application code, all these different source codes are available. Putting into a Git repository, updating in the different version control, and then I run my CI/CD pipeline. So this CI/CD pipeline could be the technology partners, tools, right? It could be my service integrators, whatnot. All these different tasks I started creating as a workflows from the infrastructure automation point of view. Right. So Prakash, any thoughts on the GitOps? We
Yeah,
do have
this
the
is
GitLab, but just wanted to connect
yeah,
the
this
dots.
is fantastic. So when you say CI/CD, it includes a lot of things, as you said. Like example, if I have a let's say, let's take some example, industry example.
Yeah.
So Ericsson has a product for, let's say, uh, G node or E node for the 5G. Now they may be developing, but they also have to work with other operators. Example, it could be a backhaul of MPLS, and that could be Cisco. And they may have to work with maybe VMware for the data center. So when you have this kind of a combination, and if the customer happens to be either AT&T or Verizon, just as a sample example for a telco, then for that, these three people have to work together. Now, each one cannot have their own separate, each one can have their own separate CI, but when it comes to deployment, deployment doesn't happen in their place. It happens in the data center or in the network of AT&T or Verizon, example. So then what happens? How do you do the CI? You can do the CI, you can do the staging, but not the delivery deployment, actual deployment. So you can do the staging deployment at your place, and this is called third-party CI. So that is where you will find in OpenStack and Kubernetes, they all support third-party CI, because what it means is the customer owns the deployment, but the third parties give the CI. And GitOps is, so they have example in Airship example, there is a treasure map, and you have a network cloud, which is what the AT&T uses. Now that network cloud is, so there is something called upstream, downstream. So the upstream is what, which is open source, available to everybody, and they can take a downstream, like telcos like AT&T and Verizon can take downstream. They can take from the community what is available, and then they can deploy on top of it, including whatever the artifacts which are given by examples of Ericsson's and the Cisco's. And it may happen that we may do it with OpenStack. Example, our folks in India are working on OpenStack to manage the OpenStack, cloud native OpenStack. And that's what we are going to hear here from coming from OTF and coming from the FROS. We are going to see those things being used in government of India. So we are going to go towards GitOps. That's a normal thing. And it's not just GitOps. You can also have ML ops, machine learning operations. You can have similarly AI ops. So these are various things which we will see as emerging, and we want our faculty and as well as our students to learn about it. I think I'll stop. Thanks.
Pretty good, Prakash. So this is exactly one of the thought process for further discussions, for their further reading from the teaching faculty, right? So what I put together for your own benefit is put together some kind of a questions related to the cloud infrastructure, day 1 to operations, what could be the SLA, the topics which you covered. So I kind of put together some questions so that it is good for you to further reading. I have given, in fact, you can definitely shoot an email to me if you have any questions. But for the reading point of view and for your own consumption, already put together for the different thing. So feel free to connect and then reach out to us. But again, just to close, Vipin sir, thank you for giving us an opportunity for talking to this entire teaching fraternity, right? So we would like to take this ahead in terms of connecting the dots. What I mean is, how do you establish a connection between industry and then academia? This is very, very important for all of us, and we are here to help you. So thank you very much again, and then looking forward to it.